What's up everybody guys, welcome back to Miyamaru tutorial. So what are we gonna make is like this. Yeah, finally we don't need to use KINECT. So generally the new version of the Touch Designer implement the body tracking system, so which allow us to track the human skeleton. So that's really cool too, right? So I'm gonna implement this visual with body tracking job, and also I'm gonna explain about some a GPU protocol. So I will use the computer shader. Yeah, it might sound a little bit complicated, but it's not. I will explain clearly so you can get it. Before I get started, I started the Patreon. So my Patreon have a lot of service. So but basically you will sample file in my Patreon. So if your file doesn't work correctly, double check your process before you download sample file. Okay, and if you want to get my sample file, check my Patreon. Okay, let's get started. I'm gonna add the body track chop, this one. So if you don't have a body track chop, you need to upgrade your Touch Designer to 2023. Body track chop work only on Windows that has a NVIDIA GPU. So I highly recommend to switch to the Windows. I know it's very expensive, but it totally worth it. So I highly recommend it. Okay, so body track chop has a lot of function, but first of all, I'm gonna enable the body people tracking, and I'm gonna change the max bodies 1. And then now I have a error. That's because I don't have a top here. So I'm gonna add the device. I'm gonna use the video I already recorded, so I don't use this one. So I'm gonna add the movie file in, and then I recorded the stream. Okay, this video. So I also highly recommend to record the video at first, because if you want to test it out, you need to stand up from the chair, and you need to move it. That's not efficient. So but I'm gonna use the movie file in first. So to change it whenever I want, so I'm gonna add the switch, then I'm gonna add the no, and then I'm gonna drag and drop to the top. So now you can see a bunch of the information here. Yeah, looks super scared because what's going on in here. But basically here body track chop has information about each joint of the human body. So it's so shoulder, ear, a lot. That's a lot. So I'm gonna visualize this information because it's easy to see. First of all, I'm gonna add the trim, and then I'm gonna change the unit values to the absolute and 0 to 0. So now you can see this chop tracking the each frame, but here now I only get the one frame. So and I'm gonna add the null, and next I'm gonna add the delete, because there are some information that I don't need. So I'm gonna add the delete channel, and what I don't need is the box and asterisk. Okay, also there is some information that I don't need, so I'm gonna add the select, make it clear all the time. I'm gonna type this column, and then I'm gonna select the UV. Okay, now it's very simple. So next I'm gonna add the shuffle. Okay, and the method is every nth channel, and then in values 2. So and I'm gonna change the name I'm gonna have to rename. So first one is a TX and second one is TY. And I'm gonna have the null. So and then I'm gonna add the math before null here. And then I'm gonna add the constant chop from here. And then the first column is resolution X and the second one is resolution Y. So I'm gonna like there some expression. So population dot new mistake width and Y is the height. Okay, cool. And then if you go to the mult add section, and you can see the mult. And I'm gonna add the some expression. So constant one parentheses, and then I'm gonna specify res x and divide it by. So I'm gonna copy this one. Yeah, bien sûr. Y. No, sorry, it's opposite. First one is Y, and second one is X. Okay, perfect. So now I need to specify the name. No, the position. Because there's just sample, but I'm gonna change the position of the each joint. So to do that, it's a little bit complicated, but I'm gonna show you easiest way. So let's go back to the body track chop, and I'm gonna click on the right click on that, and you can see the operator snippet. So I'm gonna open the operator snippet. Okay, you can see it, and I'm gonna dive into the body track. Go to the geo body 2D, and you can see the skeleton geometry and the script that and the null body primitive. So I'm gonna copy and paste these three, the copy, and then paste it to your project. And then just in case, I'm gonna delete the operator snippet because it costs performance. So okay, cool. So I'm gonna add that sub that two sub. I'm gonna drag and drop to the point that I'm gonna drop to the point that, sorry, not this one, here, point that, and then I'm gonna delete it. And next one, I'm gonna add the new constant, and I'm gonna add the new channel, and the first one's name is TX, and second one is TY. And then I'm gonna change the number of sample. So it's gonna be, so I'm gonna change the sample, and the sample, the end is 11. Okay, so I'm gonna add the null, and then I'm gonna add the limit chop from the null, and the X channel is TX, Y channel is TY. So and then I'm gonna change to the that. So I'm gonna add the sub2. Okay, perfect. So and then I'm gonna add the sub2 the point that. Sorry, I need to change the here. Channel is 33. So now I don't have an error. Okay, because so there is the order of the joint. So and then they have a 35 index, and I already specified the 33. So which means I at the point for the skeleton expect the beginning and the end. This means you can see the how to connect the joint. So for example, if you want to connect the joint from the shoulder to the upper arm, so you need to specify the number of the shoulder and then upper arm. For example, so left shoulder and left elbow. So the number 33, it's gonna be a joint of the shoulder to elbow. So all rules is here, and then this read the rule. That's cool. Okay, I'm gonna add the chop to. So finally, I'm gonna change the location from the chop. So I'm gonna drag and drop here. But I don't use the TZ, so I'm gonna delete it. Also, I don't use this one. I'm gonna delete it. So now you can see. Yeah, cool. But something off, because here I multiplied both tx and ty. That's not correct. I only wanted to multiply to the ty, so I'm gonna change to the ti to the +1. So now, yes, work perfectly. So now I can visualize it. So just in case, I'm gonna add the wireframe. Too more thick. It's too much. It's like Fall Guys. Okay, and then I'm gonna add the geometry. Pitch. And I'm gonna add the constant. Math. Okay, perfect. So now I'm gonna render this geometry. So I'm gonna add the camera. Where is camera? And the render top. So and then I'm gonna bring this top. I'm gonna add the node to here. Okay, so and I'm gonna change the setting of the camera. So not view. So I'm gonna change the orthographic. And then width is 1. And the X form is 0.5. And then I'm gonna change the ty. So it's gonna be null 2. Null, not 2, null 5 is this one. Null 5 that height divided by null 5 dot width divided by 2. So now my camera is the same angle from the null. So now if you add the over, and then if I composite, so now I can visualize, right? It's worked perfectly. Not perfectly, but it's almost correct. That's the basic of how you visualize. But if I stop here, that's a normal YouTube channel. But it's me on my own YouTube tutorial. I'm gonna make the interactive experience with this one. Finally, I'm gonna make the tutorial for GPU particle. I know I really wanted to do that, but I always hesitate to make that because everyone makes it. But that's pretty cool. And also if you get how you use the computer shader glsl, so you can expand your skill definitely. Now I'm gonna make some particle, GPU particle. So I try to keep it simple. So I'm gonna add the glsl. So and then before doing that, I'm gonna add the new constant and then width and then height. So width is 128. Okay, so first of all, I'm gonna make the initial position. I'm gonna write some code. X is VUV, not X, it's a LED. S and VUV dot T, and the blue is 0.0 and alpha is 1.0. Okay, that's it. So if you click on the here and then right click on it, and if you click on the view as a point, so you can see this is a few instancing the particle. If you click on the V, you can get it back to the this view. So I'm gonna drag and drop this setting to here. Yeah, okay. So and I'm gonna add the new glsl. So I'm gonna use a glsl, and also I'm gonna add the noise. and then change to the not monochrome period is 2 at the abs time dot seconds, maybe 0.5. And then I'm gonna change the pixel format. This is super important to the 32-bit float, because like if you specify the 8-bit, so you can only use the range that from the 0 to 1.0. I'm thirsty. Okay, and I'm gonna add the mask. So and then I'm gonna change the range to the minus 0.01 to 0.01. And then I'm gonna connect it here to second input. So this is gonna be false. So I'm gonna explain after. And also I'm gonna add another noise. I'm gonna change the area, and then also I'm gonna add the abs time dot seconds. Time dot seconds multiply 0.1. And then I'm gonna add the mass. And then I'm gonna change the range to 1 divided by me time dot rate. Okay, so I'm gonna copy and paste and multiply 2. So this is gonna be life of the protocol. So you will see. So I'm gonna connect the third input. I'm gonna add drag and drop to the distribution. This one. Okay, and go to the glsl2. I'm gonna use the computer shader. So I will explain about computer shader or like a GPU protocol after that. First, I write a code with some short description. I'm gonna also like change the output access to the read and write. And I'm gonna turn off the clear output. And I'm gonna change the color buffer to 4. And I'm gonna add the new vector. So first one is U light. So I'm gonna add the 3 to here. This is a U FPS tick. This is like how many like second in one frame. 1 divided by me dot time dot rate. And third one is U less. That's a resolution. So I'm gonna drag and drop to here, and this one as well. So last one is U speed. Okay, cool. That's a kind of basic setup. So and I'm gonna write the code. So this is for the pixel shader. So I'm gonna close it, and I'm gonna open this one. This is for compute. So make sure you need to like write the code on the glsl compute. So I'm gonna open it. So I usually use like a text editor, so which is like a Visual Studio Code. If you change the I think here preference, yeah, and then go to the dot, and then here is the text editor. And if you like specify the location of the text editor, you can use it. First of all, I'm gonna declare the uniform, which is this one, the vector. So when you use like a variable of the vector, so you need to specify it. So first of all, uniform float U light, and second uniform float UFPS tick, and third of all, uniform. This one is vector because it has a x and y, so it's a U-less. Third one is uniform float U speed. So in GPU protocol, the basically always same. So they need position, velocity, force, life. So that's a super basic. That's the information of the protocol, right? So I'm gonna add the spec for position, and I'm gonna use the image rows parentheses mtd compute output and 0, and I vector gl global invocation ID and x and y. This one means you can get the image at the previous frame. It's a good point of the computer shader. Pixel shader can't do it. Pixel shader is kind of stupid. They always forgot the information of the previous frame. So you don't want to date with the pixel shader guy or girls because always forgot the memory. But if you date with a computer shader, he's always remember the memory. So that's really good. Okay, so next one is a big flow. Is velocity. So I always kind of suggestion, because I subscribe to their GitHub Copilot. It's very productive. So, and then third one is life. You know it. Yeah, life is the image load and compute output. This one is a kind of index of the pixel, but you need to be careful. It's not the UV. So usually this one has a index. So it's like 1, 2, 3, 4, 5, 6, blah 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 blah. Not 0.01, 0.02. It's not UV. Okay, that's a difference. Okay, so I'm gonna add the new one. So vec4 init pose equal. So now also can get the texture. So this one is texel fetch parenthesis std 2d inputs 0 because this one is the initial position. So and then this one is a 0. Okay. Vec2 and the gl global invocation ID dot xyz xy comma 0. I'm gonna change the position of the y. So init pos multiply equal u less dot y divided by u less dot x. Okay, next is a vec4 is life variant. Also, I will get the third input. So I'm gonna copy and paste here, and input is 3. Okay, next is a vec2 pos index equal clamp position dot xy and vec2 0, vec2 1, and then position index multiply equal position index dot y multiply equal u less dot x u less dot y, and vec4 finally pose equal. So I also can use the texture. So texture function that you can use it in the pixel shader. So like std input next one is a 1 and the pose index. So that's why I made a pose index. So what I want to do is making the vector field, but it's more like clear to see. So for example, the particle now is here, and if the particle go here, I want to add the force like this one. So if I add the force to the particle goes here, and then here is no like a force, So the particle, like a hue and stop. So now we have a this type of the image from the body structure. So the particle, the goes to here. So I want to add the force by the image shape of the body. So it goes here and goes here. So if the particle bursts from here, it's at the force immediately. Okay, and then last one is the velocity. Velocity dot xyz plus equal force dot xyz multiply u f p stick multiply u speed, and then position dot xyz equal plus equal velocity xyz plus u f p stick, and then so the particle always have a life, right? And if the life is end, so for example the particle has a 3 seconds of life, and each frame the life is subtract by the time. So if you takes the 3 second, particle is die. So if the particle die, we need to assign the life again. So that's why I always suggest the GitHub Copilot to suggest me this one. I don't want to use if function because in shader language, the if is a little bit heavy. So I'm gonna show you how you calculate the life without if. So okay, life dot x equal life variance dot x minus equal life variance, and then life dot yz equal vector 0 because I don't use it, and the life dot w equal 1.0. I also don't use it. So next one is important. So position dot xyz equal, I'm gonna use a mix, and init pose dot xyz, and the position, it's a current position xyz, and then you can interlap with the last value, third value. So, and then I'm gonna add the step 0 and the life. That's a life. So this is how to initialize the position with along the life. If the life less than 0, this value is gonna be 0. But if the life more than 0, so this value is 1. So okay, the life is 0, the position is init pose. Otherwise, you use the position this one. Okay, and the velocity as well. So in the velocity, the initial velocity is 0.0. But now I didn't initialize the life. I need to do the same thing for the life. Life.x equal mix u life and life x step 0 and the life x. If the life is not a 0, I use the life. But if it's 0, I use the u life. So I think it's a 3. So if the particle is died, so the life is gonna be 3, but otherwise use the life like a 2.2 or 3.1 to the getting degrees. Okay, and then last, so we need to store the image. So here is super simple. Just specify the position at first. So the index 0 is a position, right? Okay, yes. Next is a velocity. What is the next? Is a life. And I just, in case, I also do that for color at the fourth buffer. So, and I'm gonna save it. And back to the editor, there are some error. So let's open error. Oh, here. Yeah. Life variance is 2. No, 3. Okay, it worked. So and I'm gonna clear and so let's see each buffer. So I'm gonna the render select and 1, 2, 3, 4. If you at the top here, first is 0 and second is 1, 2, 3. So I'm gonna the new and copy paste. Connect it. So I'm gonna call it the position, and I'm gonna call it velocity, and I'm gonna call it life, and I'm gonna call it color. So let's go instancing. So I'm gonna the sphere, and I'm gonna the transform, and I'm gonna the geometry, and I'm gonna the constant mat, and I'm gonna apply it, and I'm gonna change the scale of the transform. So it would be 0.001, 2, I don't know, here, and I'm gonna the camera, and I'm gonna the render. Only specify the geo2, and then I'm gonna specify this camera, and then here I'm gonna change the set view to the orthographic and 1, and then translate x is 0.5, and then y is you need to go the GLS 2 and go to the resolution. I'm gonna copy parameter and then paste it here, and I'm gonna copy it and paste it, and then first is y and divided by x, okay, and then divided by 2. So now it's perfect position. So we should do an instancing, right? So let's go instancing and turn on the instancing. So I'm gonna drag and drop to the position to the translate OP. X is RGB, and then go to the color. So I'm gonna have the color here and RG. Okay, now you can see this tile. So I forgot the one setting because here is, it's not correct. So don't forget to change the pixel format of the glsl one. So now I already added some force from like noise stop. So that's why it's a little bit moving. So now I'm gonna show you like interesting way, and you will get the point to add the force from the skeleton. So I'm gonna add the circle, and it's looking big. I'm gonna change the size, and then output is only set only also a little bit big, and then I'm gonna insert operator, and I'm gonna multiply and then connect it, and then I'm gonna clear it. But if I change the position circle, so you will see the effects. I'm gonna So if I change the position, wait, I should change more. So I'm gonna change more, 0.1, 0.1. Looks good. Yes, like this one. So you can add the power, add the force with a circle. So basically, this position, this the like vertical position, and like how when we add the scale and when we add the force is the same. So go to, get it up. Yeah, you get the point, right? Okay. So what we want to do is like I'm gonna change to the circle to the skeleton. So I'm gonna only render G1, and then I'm gonna just add the fit to here. I'm gonna use the same width and height. Okay, perfect. And then I'm gonna add the blur, and then finally I'm gonna change to the mount here, and I'm gonna make it more bigger. So what about 0.2, and I'm gonna clear output, and then let's see. Okay, looks cool. I'm gonna add the feedback. So let's open the palette, and you can see the feedback and connect it. And then if you add the over, and then I'm gonna connect it to here, and then if I connect it from render to here, you can add the node. And if you want to do like a projection, you need to add the window and up here and do a projection. But the one thing you need to be careful when you do a projection is the brightness of the camera. You can't get the correct position from the camera because it's very dark. Let's try at the level. So it's try to make it black. So let's go here. Yes, it's not working anymore. So you need to be careful. So I think it's a difference of the using the KINECT or using the webcam. Okay, that's a simple effect with the body tracking, body track chopper and the GPU particle. So next I'm gonna like a deep dive into the more particle. So there's like some problem of the particle, and also we can like track the multiple person. So I'm gonna show you how to do that in the next video. So thank you for watching my YouTube tutorial, and if you like it, please like it. Please push the like button or subscribe it. And if you need a sample file, let's check it out my Patreon. So bye.